So with all of that groundwork laid, let's go ahead and define some inputs for moving our PC hovercraft around. So double click it to open up the blueprint editor, and it'll open, and mine it defaulted to the event graph, so if it's not there, go ahead and click the event graph. We have our jump working the way that we want it to for the time being. So let's add inputs for our other actions. Actually, before we do that, let me introduce another concept to blueprint editing. I'm going to drag select all three of these nodes that we were using to define the jump behavior. I'm going to press the C key. That creates a comment box, and so it kind of is a useful way to organize the functionality inside a blueprint. So in this case, I'm going to name this comment or label this comment jump logic. Right, and so then when this thing becomes huge and we have just a ton of information in here, I can scroll out and I can see, okay, so this is the section that talks about jump logic, and I can zoom in and edit what I need to. So compile, save, and that leaves my comment there. All right, now let's go into moving forward and back. So this time, instead of defining the behavior as a result of an input action, I'm going to define the behavior of an input axis. So I'm going to click that. I'm going to type that in really quickly. Actually, I lied. Input. And then let's talk, since we're talking move forward, let's type input move. It's going to bring us up an axis event. Input axis event move forward is what we're looking for. So we click that. And it's very similar to the action, right? The action has a pressed event that's executable, a released event that's executable, and a key data output. The axis event has the event itself being called, and then it also contains a value output. We're going to use both of these to define what happens when the move forward key-bound key is pressed. So when the axis value is anything except for 0 is when this is going to execute. So in our case, since this is a keyboard, it's just going to be whenever the button is pressed down, whether either any key that's bound to this axis is pressed down. So let's define what happens. So what do we want to do when this is moved forward, or when the key to move forward is pressed? We could look at it a couple different ways. We could look at it in terms of movement, right? We could move a component to, say, a location that's out in front or out behind. We could, let's see, we could just go in and change this thing's location. I'm just going to be down here under utilities transformation, set actor or set world location for the body component. Perfect. So new location. So we could literally just set it, give it a new location, so it doesn't actually move. It just kind of teleports in small increments. We could actually make it so that it sweeps, so that it kind of goes right along to it, or it teleports. We could do it that way. I don't want to do it that way though, because if you take a look at what we did with our jump, we added an impulse, which is a physical force. Not really a force, because it's not continuous. It's just an instantaneous force, a force applied at an instant, which is defined as an impulse. But it's a physical phenomenon going on. It's not a digital, the computer is telling me to move a certain amount of space. It's simulating a physical force. So when we press the move forward key, what I want to do is add a physical force to this body, and that's going to push it. I literally want to push it as if it was being pushed by a thruster or like a rocket, right? That's what I'm going to be simulating when I move forward. So I'm going to drag off the execute node on the input axis move forward node, and I'm going to type in add force. And would you look at that? There's a physics function to add force to a component, in this case the body. Boom. And once again, it's very easy. If you just have the add force node, you can drag a reference to the body component and then connect that to the target. Alright, so the add force node requires a target. That's what it's adding the force to, and then it wants to know what the force is. So to make something jump, we added an impulse that was positive in the z-axis. Right? To move something forward, right? We always talk about, I have been talking about rather, the axes that all objects exist on in Unreal Engine. Z is up and down, Y is left and right, and X is forward and back, right? So one would imagine that in order to make the thing move forward, all I need to do is add a force in the x-axis, right? So I'm going to add a force. Let's add a force of 20,000. Kind of sort of in the same neighborhood as that, but less, because I'm going to be adding a force every single frame. Every time the processor is told to go through the game execution loop, I'm going to add a force of 20,000 units. So that'll add up pretty quick. So let's press it. See, there's too much friction while I'm laying on the ground. But if I jump and press forward, hey, look at that. It's working just fine. Oh, fell off the edge. Get back to the origin by pressing play really quickly. That'll bring my camera back. Alright, so it definitely works, but it's not... well, let me try to jump backwards. I'm pressing the S key, and it's still moving me forward. Let me... Oh, see, I'm not even pressing any key, and it's moving me forward. That's not supposed to happen. So let me see what's going on here. Anytime it's being pressed, we're moving forward along the x-axis. That's not what we want. We want to use the value of the axis and translate that into a force. Alright, so let's do that. So when the axis value is anything other than 0, we want it to reflect whatever the value of the axis is. So I'm going to take just a quick second. This output node is green. Everything in the Blueprint editor is color-coded. Green stands for float. A float is a number that can have a decimal value. So that right there is a great example of a float. 9.9999984 is definitely a float. So that's the easy way to look at it. Float is short for floating point decimal, which means that the decimal can exist anywhere along in the number, and it's kind of the most commonly used data type that is simply just a number. You also have, there's a lot of different types of variables that are usable in Unreal Engine. In terms of numbers, the other one that's commonly used is an integer. Integers, if you're familiar, are just the whole numbers, so -10, 1, 0, 8,100,000, and 7. Those are all integers. If it has any kind of decimal, though, it cannot be an integer. It is a float. And so when you have a non-zero value for the move forward, this axis value is going to be output as a floating point decimal between, and if you remember when we defined our inputs, this is going to be between -1 and 1. So these are going to be very small. So we're going to need to alter it a little bit in order to get a useful value out of it. We're going to multiply it by a large number. Before we do that, though, let's prepare this add force node to receive the value that we're going to get eventually using this one. The way we're going to do that is, if you can see this is not green, this is yellow. And that's because this variable type is a vector. If you read the force vector. A vector is 3 floating point numbers, one corresponding mapping to the x value, to the y value, and the z value. And this can be, if you actually take a quick look here to the right, this transform component of our blueprint is consisting of 3 vectors. One vector is the location, so the value here, x, y, z, that would be a vector. Rotation, x, y, z, that's stored as a vector. Scale in the x, y, and z axes also stored as a vector. So a transform is a data type that consists of 3 vectors. 1 vector, 2 vector, 3 vectors. And a vector itself is a data type that consists of 3 floating point decimal variables. 1, 2, 3. 1 for x, 1 for y, and 1 for z. Alright, so we need to get from a float to a vector. Easiest way to do this, in this case, is to right-click here on the vector area of the input for the add force node and split the structure pin. And by splitting the structure pin, what we're going to get is access directly to each of those floating point values. So we went from a vector into 3 separate floating point inputs. Alright, that's just a semantic thing. I haven't changed the functionality of this node at all. I've just made it so that it's easier to plug this in. So, we were talking about changing the force on the x-axis. So let's drag this axis value item here. And what do we need to do? Oh, we need to multiply it by a large number, right? So let's type multiply. We've got a lot of different functions that we can add. That little f right there means function. All right, and so we need to multiply this float by something. We could do a float by a float, or a float by an int. Theoretically, doing this float times int should be more efficient than a float times a float, but I'm not entirely sure that that's even true. And regardless, it's going to be a very minor thing. And again, this is a very simple game, so the difference in performance is probably going to be super minor. But I went ahead and did integer just because I don't need to multiply this by a decimal, so it doesn't really matter. So the axis value is going to be at most 1 and at least -1. And if you remember, we tried 20,000 and it still wasn't moving while it was on the ground. It could only move while it was in the air and it wasn't subject to friction. So let's try 50,000 here. Compile and save. Oh, we haven't attached it to anything. Alright, so we're going to change that to force in the x-axis. So now, when we press W, this will be positive. Multiplied by 50,000 will give us a force that is positive along the x-axis. But when this is negative, it's going to multiply by a positive 50,000 to give us a negative force along the x-axis. So it should make us move backwards when we press S. So we're going to hit play. Alright, and now I press W. Alright, I still can't move while I'm on the ground. But if I press W while I'm jumping in the air, I can move forward. And yep, when I press S, I move backwards. Alright. Uh-oh. I think we might be able to see the next thing that needs to be corrected here. If you'll see, my hovercraft is rotated. But when I press W, yeah, see, now it's even more pronounced. When I press W, I'm not moving forward. I'm moving along the x-axis of the world, not the x-axis of my blueprint. Ah, okay, so that brings up a very important point. This add force is the input for this is in world space, not in local space. That's a really important distinction. So if we go back to the viewport right here, the x-axis, as you can see, for any objects that are placed, the widget will tell you the x-axis is pointing off that way. So even if I rotated, if I had turned that hovercraft 90 degrees this way and I had pressed W, I would have gone this way instead of going forward. And so we need to teach the blueprint how to move properly. So rather than applying a force in the x-axis. I like that 50,000 so far. We'll leave that alone. Actually, I'm going to increase that now. Rather than add a force in the x-axis, to the x-axis, we need to add a force in the forward direction of our body. All right. Fortunately, Unreal Engine makes that very easy. So I'm going to do another add force node. Add force to the body. That looks good. But now, instead of typing in a value or plugging in a value to x, I'm going to input a transform, a vector into this vector input node. And the vector that I want to put in is the forward vector for the body multiplied by the scalar value of this axis times 70,000. All right, that sounds pretty complicated, but it's actually quite easy. So I just need to tell Unreal Engine to figure out which way is forward, and then multiply the axis value by 70,000 and multiply that by the forward direction, and then add that force, that calculated force, add that to the body. So I'm going to take this body pin, I'm going to drag off of it, and I'm going to call a function from the body, and that function is going to be called forward vector. Get forward vector. Boom. Not only is it the data that we need, it's in the correct format. It's a vector. So now I'm going to drag that vector value. I'm going to, remember, I want to multiply, so this vector value is going to be 1. That's the magnitude of that vector, and it's in the direction of forward from this body. So I need to multiply, because it's not a very long vector. It's just 1. So I need to multiply this vector by a float, and the float is going to be the return value from this multiplication node here. Drag that in together, and then look, when I multiply a vector by a float, it's going to multiply all 3 values by this float. So it's going to multiply x times 70,000 times axis value, y times 70,000 times the axis value, z times 70,000 times the axis value. So then I'm going to add that in. I'm going to plug that in right there to the force input of the add force node, compile, and save. And that potentially really complicated problem just got really easy. So now, as I rotate, now when I press W and S, I move in the correct direction. It's just that easy. Alright. So that's problem number 1 solved. Let me go ahead and comment that out. Call this move forward. Compile and save. That seems like a pretty good place to stop, as this video is kind of going long as well. Next video we'll cover turning left and right.